Alrighty, Mr. Gatekeeper here. I have here a Messenger. It's not written on the front, but I believe, if my memory serves me right, I think it's called a 350 AB bias 350. I could be wrong about that. I don't have a chart right here in front of me, but it's four 455s, four Motorola 455s. So basically, the kind fellow sent me this saying that it was not keying and there was no output. Well, here's why it wasn't keying. Well, this relay right here, for one thing, is shot. And you can tell this thing has failed a few times. Somebody got kind of smart and creative and put some quick disconnects right here, some sockets. They cut up some 6-port sockets to accept the transistor for the preamp and the transistor for the keying circuit. That's pretty cool. That's pretty cool. If it ever pops on you, you can just replace it. You know what? That actually is so cool that I may actually start putting these on Texas Stars. See, one person can never think of it all. Whoever did this, if you're watching this video, if you ever watch this video, shoot me a comment and tell me it was you that did it. I'd like to give you a thumbs up on that, because that is a pretty creative idea. It's one of them things that's so simple that you don't think about it. Because Texas Star keying transistors go out all the time. It's the most common thing that goes out. If they just had a simple socket on there, the customer wouldn't have to ship it all the way over here to me to replace a keying transistor and waste his time. So, but anyway, this has had a lot of work done to it. You see, these had to put the sockets on there, trace repairs, there's a resistor blown right here. It's like one of the inductors for the AB bias switch over is blown. At this point, man, this would have to be removed anyway to go through here and repair all this. So honestly, at this point, it's almost just better to go ahead and do away with the board, which I do a good bit actually on Messengers, and just go ahead and do this right here. Now, I knew I had drew a diagram sometime in the past, but I couldn't locate it real quick, so I just drew me another one's right here, and I'll just kind of leave this right here up for a second for reference, just in case anybody's ever watching a video and they're needing to do the same, or they're just wanting to use this for reference for a future repair. And basically what that is that's a diagram of these points right here, which are on the board. This would be 1. That's a ground part of the ground plane of the board right here. This would be 2. So that would be the SSB for the SSB. That would be for the positive of the coil of the main relay. This is your switch on, go into the bias circuit, which would be 3. This would be 4, which is for the front relay, going to the input of the high-low medium switch. And then this right here would be 5, which is to the relay RF out from the amplifier, from this real quick filter circuit, another ground plane. And this right here would be 6, which is the positive for the relay, and then another ground plane. So, like I said, I'd just leave that up there just in case anybody in the future is wanting to use it for reference. So, that's what I went ahead and did for you, man, is I went ahead and built you another preamp, installed that for you, another main relay, keying circuit. This right here is your relay now for your bias. The way that they did that on here, instead of having a third relay, which you will see this done this way a good bit, they're utilizing inductor and capacitors. You know, basically letting the DC flow through the inductors and letting the DC be blocked by the capacitors, AC be blocked by the inductors, DC be blocked by the capacitors. So went ahead and utilized a relay for the active switch on for the bias, and then there's your SSB delay capacitor. So after I went ahead and did that and got the front end of the amplifier repaired, then it was time to see if this thing was going to produce any RF, and it wasn't. There was full-blown input reflect coming back to me, and the problem was right here. This has also been repaired a few times, and the problem is on these boards, when you get to putting heat on these tiny small traces, they'll start to fold up and then break off. And I should have took a pre-video, a picture of this, but basically right here to right here, there was just a big glump of solder gook, and I mean, it was nasty looking. I don't even know. I knew what had happened. The trace right here, as you can see, it's gone now. From here, let's see if I can point. From here, this is basically the common of the switch. From here to here, that trace right here is now gone. So somebody had tried to put solder on that trace while it was still hanging, and there was just a big clump of solder from here to here, and it wasn't making connection. And guess what? The one over here wasn't making connection either. So this whole, both of these were not making connection. So the RF was coming back to the radio. So you were having pretty much just like you didn't have your radio hooked up to a load. You could have fried your radio very, very, very easy that way, not knowing and what's going on. If you ever key an amplifier and you don't see power coming out, do not key again. Stop keying and get that thing looked at by someone that knows what they're doing, because you never know. You could be having all of the power coming directly back to your radio, about to fry it, and you wouldn't even know if you don't have a meter in front. So I went ahead and repaired this trace right here real well with a piece of solid copper on this end. And then on this end right here, I went ahead and did a solid piece of wire. And also, this is doing one or two things. This is carrying your RF to the common of the switch, and it's also here for sturdiness. Look at that. It's not even moving now. It was a little flexible before I did that and that. So that's playing two different things there. So I had to fix the front end of the amp there, and after I did that, the amp came to life. And then the only other two things that I really did was I cleaned up the amp a little bit. Okay, and another weak part of this amp that I do not agree with how they designed these. If you will now come and look right here. Right here. Well, as you can see, I've already put solder right here and thickened this up. This is your hot bus carrying the DC current over to your, on the back of the transformer, feeding the collectors of your transistors. This is feeding the power to your transistors. And the way they do this, they bring this 8-gauge wire. It's just really an AC wire. They bring it in and put it right here at the very end, which I don't know why they even do that, but that's just what they do. They put it right here on the very end. So, and then they expect the DC current, possibly up to 30 amps plus, maybe even more at times, to flow through a paper thin, thinner than paper actually, piece of copper to here, and then flow through paper thin to here. So this one could be starving for current a little bit. So every single time I always like to go through right here and thicken up. Thicken up, you see what I'm saying? Now, this guy didn't send me a message and say, Gatekeeper, work your magic, or Gatekeeper, do your thing, or, you know, Gatekeeper, do whatever you feel it wasn't really a deal like that. It was just a simple, hey man, it's not working, fix it. You know, now if it was one of them type of deals where he just gave me complete open door, I would have done a few other things that really wouldn't have helped. For say right off, you know, on the meter you wouldn't see results, but just things that could possibly help, possibly down the line, you know, like a power wire upgrade. Now these power wires are pretty thick, so that's fine. I'm happy with that. I'm about to run out of space. I didn't even notice that till now. I think I can clear up some videos. But anyway, I mean, they're thick enough. They're fine. But I'm just saying you could go with some thicker wire and then erase this fuse holder. This fuse holder is, you know, holding back a little bit of current. You need your fuse holder at your power source, at the battery. Of course, there's nothing wrong with having one on the box. This is what I call politically correct. But it ain't something that's absolutely needed. It's just one of them things we like to do, you know. Now, if these were 100-watt transistors, then, you know, I probably would give you a call. Alright, so let me actually, I've only got 40 seconds. I ain't even going to try to cram in showing the output of this within that amount of time. I'm going to press stop and go ahead and clear up some space. I'll be right back. Alrighty, I'm back. Alright, before we go ahead and see this thing working, it had about a half a watt of input reflect. They had a 100 picofarad load right here. I went ahead and threw a trimmer right there and just tuned it down just a little bit and was able to get it from pretty much around a little bit over a half a watt actually of input reflect down about half that. So I was able to get it down just a little bit more. I always try to fine tune these things when they get it here on the bench while I've already got it out. Next thing I went ahead and did, which everybody knows is something I always do. I hate leaving trimmers and amplifiers for people to turn, and I especially do not like leaving trimmers sitting on output on the output of amplifiers. And because you know, you've got all your power flowing through the output, and these things can only handle so much. Well, this right here would probably last no problem with this 455s. But regardless, I like to always take these out and mic them in, meaning take these out and put a set capacitor in. Because that always gives someone down the line, if you ever get rid of this box, somebody else get in there and turn it and mess the box, you know, introduce some reflect, which comes heat, which comes more reflect, which comes blown devices. And of course, with Messenger, they always have their very, very simple output filter circuit right here. A cap, coil, and a cap. I haven't actually input that into my computer to see what that comes out to, but so yeah, man, this thing's back 10/8 straight. And also, Messenger always seems on some of their circuits to have their bias a little hot, and I've seen them where they're all the way up to 0.75 volts. That's hot. That's a little hot for my taste. This one right here is sitting on right about 0.7. So, I mean, it's, you know, it's right there within the acceptable range. But, you know, just pay attention to heat. Make sure your heat sink doesn't get too hot. They've at least got the resistor that's shunted to the ground sitting on the heat sink. So that's going to help with some sort of heat compensation tracking. That's a poor man's heat tracking circuit. And also, this is not a Class C version. This thing's not designed to be driven real hard. Drive it easy. I wouldn't hit it with no more than just a single final radio, to be honest with you. If you got this thing on high, I would not dead key no more than about 1 watt into this thing. And I know it's crazy and but like I said, the bias, this thing's biased. It's towards the hot end. of the biasing spectrum, conduction angle. On high, I would try to keep it around a watt, and I'll show you here in just a second what I mean. Now once you go on low, you can dead key a little bit higher than a watt. Then always remember, on the RMS or average reading watt meter, you just want to make sure that you are not swinging backwards. If you are swinging backwards, these devices are in saturation. Okay, they are in saturation. Even though you see the PEP swinging forward, that does not mean nothing. That's just a peak reading watt meter, and it's reading peak on your peaks. That can lie to you, and you can blow equipment after equipment following just a peak meter. You want to make sure to check out the RMS reading watt meter if you're able to. And if you absolutely don't have one of them and have an amperage meter, take a look at an amperage meter and make sure you're not swinging backwards. But look, if you want to be completely precise, I don't care what kind of meter it is, if it's RMS or average, just make sure you're not swinging backwards. Not swinging at all is 10 times better than swinging backwards. Alright, so we are hitting this bad boy with the bench radio, which is 4 watts RMS, about 18 to 20 watts peak. Power supply sitting at 14.5 volts. Alright, we are on the 500 watt slug right now. There really ain't no reason to go any higher than that, where we're at. Alright, this is RMS first. We're reading the middle scale where you see the 10, that's 100. I'll just show you a dead key first. I had it on medium, I just turned it to high. So we're dead keying about 110 watts. Oh, swinging right there about 150. Oh, yeah. Here's your input reflect. 5 watt slug in reverse. Oh, yeah. Oh, yes, that's way lower. It was swinging right there about a half a watt before I retuned the input. All right, here's your peak. Middle scale. Oh, my phone died on me while I was showing the peak watts. I don't even know if it got on there or not, but just to be safe, go ahead and get this done so I can put this on the charger. Sorry, I had no idea it was about to die. So anyway, here's your peak watts, which is doing about 4 to 450. Oh, right there about 450. So I'll say that is a wrap, man. Go. What's this thing talking? No, if old gatekeeper just lets the mop flop out here around the northeast end of Georgia. 455s getting down, getting down, getting down, getting down. All right, big brother. Well, we got your Messenger back up in operation. Another amplifier back working. And I pray this thing continues to work and works for the remaining of your lifetime, my friend. And like I said, well, I didn't even show high, low, and medium. I was wanting to show that to you. This is medium. Oh, about 300 watts. Low. Oh, look at that. Dead nuts on 200. Ain't that a coincidence? And just to show your dead key differences, this is on high again. A little bit over 100 watt dead key. This is on medium. See, it's a big drop. That goes down from half a watt, let's see, 50 watts, about 25 watt dead key. This is low. Maybe like a 5 or 6 watt dead key. medium RMS. Go right there, about 100 watts. Low, right about there, about 50 watts. So there you go. Like I said, man, just try not to keep it try to keep it around 1 watt or so on high, or you'll be swinging backwards because it's only swinging 150. So if you go up higher than that, your dead key is going to be higher than your RMS swing, and that's not what you want. So you want to have a little bit of forward swing, as much forward swing actually that you can get. But let's see, I don't think there was about anything else to it. I think that's it, bud. So we'll get this thing, get the screws back on this thing and get it back to you. I appreciate you being patient. I know you had to wait a little while. I'm sure enough going to give you a discount for that, like I always do. 73s to you, bud. No gatekeeper said it. We're good and gone. 73rds. Bye, bye, bye. She says bye, too.